So in Samples and Populations problem 1.4, you're asked to do a bunch of different analyzing of the data for peanut butters in different ways. And one of the ways that you're asked to compare them is unsalted versus salted. And you can see that they're kind of mixed throughout the table. And so what I did on my chart was I highlighted the unsalted in yellow with their quality ratings and the salted in green with their quality ratings. So I used two different colors. So these quality ratings are for the unsalted and these other ones are for the salted. And you can see there's a lot more salted peanut butters than unsalted. But the idea is, how do the quality ratings compare for these? Now you can kind of just look at them and see 35, 40, 60s, 80s, and they're kind of all over the place. And so it's hard to compare them just by looking at them, because you have a variety from 11 to somewhere 83 for the salted, and then from 35, 34 to 89 for the unsalted. So the best way to really analyze the data is to use some of our other statistical analysis, like a 5-number summary and a box and whisker plot. So what I'm going to do with this is I'm going to go ahead and take these numbers, and I did this with my graphing calculator. I took these numbers and put them into my graphing calculator and had it sort the list, and so it gave me these two lists. So now I have a sorted list for the quality of salted peanut butter and the quality of unsalted peanut butter. Now, if you can't do it with a graphing calculator, you just have to find these numbers and put them in order from least to greatest. And so what I want to do now with these numbers is what I've done before, is come up with a 5-number summary. So I'm going to start with the unsalted peanut butter, and it's pretty simple to start with a minimum. There's my minimum and my maximum. And so now I want to try to find the middle. And so I can check off, starting here, work my way to the middle, 3 on each side, 4 on each side, 5 on each side, 6, 7, 8, 9, there's a lot of numbers, 10, 11, 12, 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 there. So there will be 14, there's 28 numbers, 14 on each side. So my middle is between 45 and 46. And when it's between two numbers, we go actually between those two numbers. So 45.5 is the median, or middle. And so once we found the middle, the median, then we want to find the middle of the bottom and the middle of the top. So again, I'm going to think of this as the middle dividing line between the lower half of the data and the upper half of the data. So I'm going to go ahead and again work my way to the middle, 1 on each side, 2 on each side, 3, 4, 5, 6. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And so now my 7, 7, because we had 14 and 14, now we have 7 and 7. And right there between the 31 and the 33, which is 32, is now my lower quartile, or first quartile, sometimes called. And so that's the middle of the bottom half. And again, we're going to do the same thing. So I know there's 14 numbers on each side, so I can maybe take a shortcut here and go 1, 2, 3, 4, 5, 6, 7 there. I think that's where I'm going to cut it. 1, 2, 3, 4, 5, 6, 7 there. And so between 57 and 60 is the upper quartile. So if I want to find the number between 57 and 60, I have to think about what's between those two numbers. And so at 57 to 58, and then 60 to 69, so it's between 58 and 59, so halfway between 58 and 59 is 58.5 is my upper quartile. So if I want to do a 5-number summary, and I just think of the 5 numbers that I have, 11, 32, 45.5, 58.5, and 83, the 5 numbers, maximum, upper quartile, median, lower quartile, and the minimum is what I have. Those are the 5 numbers for the quality of salted peanut butter. And we wanted to compare that to the quality of unsalted peanut butter, so let's do the same thing now with this list that again I put in order from least to greatest for the unsalted peanut butter quality. And so the easy numbers, the minimum, and the maximum. And then if I work to the middle, 1 on each side, 2 on each side, 3, 4, and we actually have a middle number in this case, and that is the median. So we can do that, median. Now when you have a very small group of numbers, like in this case, remember that when you find a middle number, you actually have to block it out. And now think of what's the middle of the bottom. There's 4 numbers, so there's the middle of the bottom between 35 and 40. So halfway between 35 and 40. So if you think of 35, 36, 40, 39, if we actually were to think of those numbers moving toward there, and then 37, 38, halfway between 37 and 38 is 37.5. And so that is the lower quartile. And then again, if we block that median out, it's middle number, and we think of the middle between these 4 numbers right there, so between 69 and 71, so 69 to 70, so 70 is between those two, and that is the upper quartile. And so now I have the 5 numbers, 34, 37.5, 69, 70, and 89 as my maximum, upper quartile, median, lower quartile, and minimum. And so to some extent you can actually just even look at the 2 things we've looked at so far. Here's the 5-number summary right up here for the salted peanut butters, and here's the 5-number summary for the unsalted. And you can even just look at the median. The median is 69 here, and the median here is 45.5. So you can already get an idea, even before we put it on a box and whisker plot, that the median on this one is much lower than the median on this one. So what's that going to do to the box? Well, let's see. Let's go ahead and make a box and whisker plot. So the quality for salted peanut butter I'm going to put in my 5 numbers, 11, 32, 45.5, 58.5, and 83. Won't worry about the IQR just in the moment. We're just going to focus on the box and whisker plot for now. And mark those on here. So 11, 32, 45 and a half, 58.5, and 83. And remember, the 3 in the middle make the box. Lower quartile, median, upper quartile. And then you connect the box to the maximum and the minimum of the whisker. And so that represents the quality for salted peanut butter. And then now if I use the data that I have for unsalted to make another one. So I'm going to move this up here. And so this is my quality for unsalted peanut butter. And so those 5 numbers, 34 is my minimum, 37.5 lower quartile, 69 is the median, 70 is the upper quartile, and 89 is the maximum. So I just transferred those numbers onto my chart. So I have those 5 numbers, 34, 37.5, 69, 70, and 89. So now I can put those on the chart, 34, 37.5, 69, 70, and 89. It's kind of an interesting box, the 3 in the middle. So the median is very close to the upper quartile. And if you remember the list of these, you can see that there's a big jump. There's a gap. So it goes 35, 40, the lower quartile is right in between there. Then you have this gap from 40 to 60, and then the median at 69. So there's a big space there, and you can kind of see that big space in the box. It shows up in the box. And then I connect here and here. Now, kind of the idea, the rule with outliers is 1.5 boxes. That's where we're going to take, this is the IQR, interquartile range, from here to here. That's my IQR. And I can just kind of at least take a look and see, is there anything that's 1.5 beyond that? 1.5 beyond that. And it doesn't look like it, so I don't think there's any outliers in this set. And we do the same here. This is a pretty big box, so it would have to be more than 1.5 boxes on either side. So when you think of the IQR, interquartile range, is the distance between the lower quartile and the upper quartile. It's a pretty big distance, so there's not likely that any of these are outliers. Same thing here. It's a fairly large distance, so it's not likely that these are outliers. So we're just not going to worry about that in this case. What we really wanted to do is to look and see how the quality compares for salted versus unsalted. And you can see that in general the box is further to the right, which would generally say that the quality overall, because remember 50% of the peanut butters are right in this box. 50%. Remember, this cuts the data into quartiles or quarters. So there's a quarter here, a quarter here, a quarter here, and a quarter there, which means half of it's in the IQR. Half of it's in here. And so even though the unsalted is a higher quality on this one and this one, the box is really what I want to look at. And the box in general is higher. So based on the data, you would generally say that the unsalted peanut butter, because it has a higher range in general, would rate higher quality. And that's where your 5-number summary helps you see that data. Part of the challenge with this set of data, however, is that you have a lot more unsalted peanut butters, salted peanut butters than unsalted peanut butters. So there's a lot more of these than there are of these, so the amount of data has a little bit of influence in terms of the overall result. A lot more here than there. So it's somewhat of a challenge when you have not the same number in each set. But either way, we can take a 5-number summary, we can turn it into a box and whisker plot, and then we can analyze the data, which is really what we want to do. Be able to say which one of these is the higher quality overall. And you can do this with any of the different attributes on the chart. We just chose unsalted, salted. We could have compared, say, creamy to chunky, or store brand to name brand, using the same techniques, choosing the quality ratings that go with each of the specific attributes and finding a 5-number summary and then using that to compare the different results in the data set. And so you can see that from this problem. So using box and whisker plots to do that.